Good afternoon, guys. These are your notes for 20.1, connecting intercepts and zeros. So the first thing we need to talk about are the zeros of a function. Okay, the zero of the function are the x values that make the value of the function zero. Okay, they're the x-intercepts of the graph. And a graph may have one, two, or no zeros. Okay, when we do this, we do it on our calculator. So the calculator steps. The first thing you're going to do is hit y equals, and then enter the equation. Next, you'll hit the graph button. And probably even better would be zoom, followed by the zero. Okay, the next step is to hit second, calc, and 2. And then it's going to say on your calculator left bound. You have to enter. And then it'll say right bound. Again, you're going to have to hit enter. And lastly, it will say guess. And you're going to hit enter again. Okay, and this step must be done on both sides of the axis of symmetry. Okay, so we're going to do 3 examples here. On page 742, numbers 1 through 3. Number 1 is 3x squared minus 9 equals negative 6. Okay, and before I can do that, I need to have it equal to 0. So I'm going to add 6 to both sides. So I have 3x squared minus 3 equals 0. Okay, and now I'm going to go ahead and follow the steps that I wrote down above. Let me zoom in so you can see what happens. So I'm going to hit y equals. Oh, and I already have an equation in there. So let me do 3x squared minus 3. And then I'm going to hit zoom and 0. And you'll see we'll get a parabola here. Okay, the axis of symmetry is the y-axis. So then I'm going to hit second, calc, which is the trace button, and then 2 for zeros. It says left bound. So what you need to do is just kind of go, because we're working on the left side of the axis of symmetry, I'm going to hit enter. Now, if you'll notice, my x is negative, but my y is positive. When I do the right bound, my x still has to be negative because it has to be on the left side of the y-axis, but I need my y value to change to a negative. So I'm just hitting the over arrow until my y turns negative. And then I'm going to hit enter. And then you can see it's telling you where your guesses were, or your right and left bound. And then to guess, I'm just going to go backwards towards the left a little bit and hit enter. And it tells you my 0 is x equals negative 1. So that's my first 0. Oh, sorry, x equals negative 1. And then we're going to repeat the process for the second one. So second calc 2. Now on this one, my left bound, I need my x to be positive because I'm working on the left side, or the right side, excuse me, of the axis of symmetry. I'm over here, but I need my y to be negative. So I'm going to hit enter. And then right bound, I'm just going to go till I see it, somewhere on the right. And then guess, go back towards the left a little bit. And so my other 0 is x equals 1. Okay, and that's how we get our zeros. So example 2, I have 2x squared minus 9 equals negative 1. So I'm going to add 1. So 2x squared minus 8 equals 0. So I need to hit y equals, and I'm going to clear that out of the calculator and put in my new, it was 2x squared minus 8, and then zoom 0. And all of these kind of look the same. Second calc 2. Again, I want my left bound to come way up to the left because we're on the left side of the axis. Enter, and then my y has to go, I have to go over till my y becomes negative. Oh, there we go. Enter, and then back towards the middle. So my first 0 is negative 2. So x equals negative 2. Or x equals, so my other 0, oh, sorry, glare, jeez. Not good. Sorry, second calc 2, and then I want my x to be positive, but my y remain negative. So I'm going to go till my x becomes positive. Go 1 into it, and my y is negative. For my right bound, I go over to the right, and then my guess will go back to the left a little, and my other 0 is 2. They won't always be the same. It's because our axis of symmetry is 0 on these that we're getting the same, well, the opposite, so negative 2 and 2. Okay, number 3 is 4x squared minus 7 equals negative 3. I'm going to add 3 to both sides. So 4x squared minus 4 equals 0. And it's the same process again. To save us time, I'm not going to go through it. It's x equals negative 1 or x equals 1. But again, you're just going to follow the calculator steps and do the same thing. Okay, modeling real-world problems is our next thing. Okay, and we're going to use a formula, and we're going to use a variation of this for the rest of the year pretty much. It's h of t equals negative 16 t squared plus c. H of t is the end height. C is the start height. So this problem is going to come from page 739, your turn number 7. Page. Okay, the problem says an egg falls from a nest in a tree 25 feet off the ground. So that would be my start height, 25, and lands on a potted plant that is 20 feet below the nest, which makes my end height 5. The function h of t equals negative 16 t squared plus 25 gives the height in feet as the egg drops, where t represents time. When will the egg land on the plant? So they gave us h of t equals negative 16 t squared plus 25. Okay, the end height is 5. That's because it said the plant was 20 feet below where the egg dropped from. So if it dropped from 25 feet and dropped 20 feet, it has to land 5 feet above the ground. So equals negative 16 t squared plus 25. Okay, and we're going to solve for zeros to be able to find the seconds. So I need to subtract 5 first. So I get 0 equals negative 16 t squared plus 20. Okay, and you're going to go ahead and plug that in your calculator and solve for the zeros twice, and you'll end up with x equals negative 1.12 or x equals 1.2 or 1.2, sorry. Okay, and at this point, because it's a real life situation, negative 1.12 doesn't make any sense. So your answer is going will just be the 1.12 seconds. Okay, you don't have to do any homework over this, but we'll be doing it in class tomorrow. Okay, so have a great afternoon.